It sees my hands. All right. So, chapter 5, lesson 2. This right here, you guys, geometric proofs are difficult. However, I'm not going to make you do them like crazy. That's why today we're going to do our worksheet together, and tomorrow your worksheet is very, like, I have blanks that you are just going to fill in. But today we will do it step by step together. Okay? I already talked about inductive versus deductive reasoning. Inductive is based on observing examples. It's not a guarantee. Deductive is based on rules, facts, definitions, laws, and stuff like that. So you got 4 examples of reasoning skills here. Some are deductive and inductive. So let's read this one. Every time Bill watches his favorite team on television, the team loses. So he decides not to watch team play anymore. Inductive or deductive? That is inductive. I wish it were that easy, right? Okay, to the right of that, all triangles have 3 sides and 3 angles. Mariah has a figure with 3 sides and 3 angles, so it must be a triangle.
Whoa.
That's deductive because it is based on facts. Triangle has 3 sides, 3 angles. Fact. In order to play sports, you need to have a B average. Simon has B average, so he concludes he can play sports. That is deductive. Now, it doesn't say he's going to be good at sports. It just says he can play it, right? He can try. Okay. And then the last one, after performing a science experiment, Liddell concluded that only 80% of tomato seeds would grow into plants. Inductive. That is inductive. It is inductive reasoning because it's based on observations that he watched over time. Okay? It's not a guarantee that only 8, if he planted 10 plants, only 8 of them would survive and 2 would die. They might all 10 survive, right? Well, maybe only 3 would survive. That's a bit bad luck, but it's possible. Okay, so proof. Here's what, and you may want to add these to your vocab. A proof is a logical argument where each statement is justified by a reason. Now, we were justifying on our worksheet yesterday. Each time we make a statement, we say this is equal to this, we have to give a justification, like because they're alternate interior angles or because they're vertical angles. Okay, everyone has to have a reason. A paragraph proof, honestly, it's informal. I think you have both paragraph proof and informal proof on your vocab sheet. They're the same thing. It's informal because it's kind of just writing a sentence. There's not an easy structure to it. I hate informal proofs, not gonna lie. I do not like writing them. I don't like grading them. So we're not going to do them. We're going to do 2 column proofs coming up here. But here's an example of a paragraph proof. Something I'm going to point out. In every proof, you will have given, and that is the first thing you start with. They're going to give you some information. So they're given information here. We got a diamondback rattlesnake, and he's got diamond pattern on his back. The measure of angle 1 equals the measure of angle 4. They tell you that. That's your given. So write a paragraph proof to show that angle 2 is equal to angle 3. So some of you are probably going, well, duh. Just look at the picture. If 1 equals 4, then 2's got to equal 3, right? And you're right. But here's how they go through and prove that. First of all, they start off with, here's your given. So the measure of angle 1 equals the measure of angle 2. Why do we know that? Because they're vertical angles. And since the measure of angle 1 equals the measure of angle 4, they told us that, then angle 2 equals angle 4 by substitution, because they're substituting the one that's equal. They're substituting 1 for 2. They're putting the measure of angle 2 in where the measure of angle 1 is because they're equal. So they use substitution. Then they go on and say the measure of angle 4 equals the measure of angle 3 because they're vertical angles. And since 2 equals 4, then 2 equals 2, also because of substitution. Therefore, angle 2 equals angle 3. And that probably looked like a whole jumbled mess to you guys, right? Okay, so let's but you kind of get it. You see how every step they had to say because of this. And in there was definitions. Vertical angles, substitution. Substitution, there's my key. If you don't know what the reason is, guess substitution. Because there is almost always one substitution or more in every proof. Okay? So let's look down here at this scissors. You guys see the scissors? Diagram AR is equal to CR. They're telling you that this AR is equal to CR. That means their measures are equal. They give us that information. And DR equals BR. I should pick a different color. So then they tell us that this one is equal to that one. Write a paragraph proof that AR plus DR equals CR plus BR. Okay, so in the given, we're filling it out. What information did they give us? Right up here. AR equals CR. That's what they start with. Every proof starts with your given. And DR equals BR. And they want us to prove this. So AR plus DR will equal CR plus BR. You know that AR equals CR and DR equals BR. There's your given. AR plus DR equals CR plus DR. See how they added the exact same thing to both sides? That's like, think back to algebra. Remember, if I subtract 5 from both sides, isn't it going to be equal? If I add 5 to both sides of an equal sign, isn't it still equal? So that's the additive property of equality. Meaning if I add the same thing to both sides, it's still going to be equal. And then look what they changed. AR plus DR equals CR plus, now they changed DR to BR. Because didn't we know up here that they were the same thing? So if I'm replacing something with another thing that I know it's equal to, what is that called?
Substitution.
There you go.
I'm just trying
Way to knock that one out. You're trying to be obnoxious for the video? That's awesome. Thanks.
Yeah, a little bit.
Okay, so that's a paragraph proof. We won't do much of those. 2-column proofs are way more organized and easier to follow. That's my opinion. Not everybody feels that way. I think most people do. Just saying. Okay, 2 columns. There will be a column on one side and a column on the other side. All right, they will, in one column, it's the statements as they go through it, and the other column is the reasons. So there'll be definitions, there'll be the word substitution, all of that stuff will come up. Okay, a couple of the reasons you might see are over here. So if you are ever adding 2 segments together, so say for example, you have a line segment and A and B and C are all on the same line, and you say that AB plus BC equals AC, duh, right? Because the first one plus it equals the whole thing, right? So we call that segment addition. Okay, if you have one segment and they break it into 2 parts and they tell you this part plus this part equals the whole thing, I feel like that's common sense, but the reason for that is segment addition. Okay, now another possible reason for your reason column, what blank states that dividing both sides of an equation by a non-zero number doesn't affect the equation, meaning it's still equal. If I divide both sides by the same number, it's still going to be equal, right? So if you find yourself doing that, if you go, okay, well, I'm going to divide them both by 5, so they're still equal, that is called, your reason would be division property of equality. Or the same thing is if your multiplying both sides by the same thing, that's the multiplication property of equality. Adding the same thing, addition property of equality. Subtracting the same thing, subtraction property of equality. So that one's kind of 4 in 1, right? If I replace one value with another value that I know it's equal to, substitution. Substitution. And I'm going to asterisk that one because if you're in a problem and you literally don't know the answer, just write substitution because there's a good chance you're right. Okay? And it's better than leaving it blank. Okay, blank states that if the same number is added to both sides of the equation, the sides remain equal. Oh, I think I just talked about this. It's just like this one, but not division, but so it's the addition property. And if you want to shorten it up, prop of equality. I'd let you do that. Or if the same number is subtracted from both sides of the equation, that's the subtraction property of equality. I just put EQ and abbreviated it. All right, or the last one is very similar to the first one. The first one talked about segments. This one talks about angles. So if I have adjacent angles, remember adjacent angles were angles that were right next to each other, angle 1, angle 2, and we'll call the whole thing angle 3. So if I said angle 1, the measure of angle 1 plus the measure of angle 2, what is that going to be equal to? The measure of angle 3, right? And that is almost like only it's going to be angle addition. So any one of those plus any definition can be one of your reasons. All right, so we'll have you flip over when you're done writing that, and we are going to practice a proof. So you can remember to turn back to these if you're not sure, and I will reference them. Nope, just that. Okay? So here is an example of a 2-column proof. Notice right on top, what do they start with? Given and prove. And they have all the statements filled out. That won't always be the case, but in this one it is. All the statements are filled out. So they tell you that M and N intersect. Duh, 2 lines, they cross. And 1 and 3 are vertical angles. They tell us that. We are going to prove that 1 plus 3, or 1, the measure of angle 1 equals the measure of angle 3. So take a look at that first statement. Where'd they get that statement? It's the given. Hey, guess what? In a 2-column proof, the first statement is always the given. And guess what the reason is? So right now I'm telling you, if you're writing a 2-column proof, you better get those first 2 right. Because the first statement is your given, and the reason is given. So the first statement is whatever they told you, and your reason is given. Okay, so they told us M and N intersect. They told us angle 1 and angle 3 are vertical. Now, look where they say. They say angle 1 and angle 2 are a linear pair, and angle 3 and angle 2 are a linear pair. Now, I'm going to point this out. Remember what a linear pair was? We kind of wrote that in our foldable. It means that they were adjacent and they make a straight line. So they add up to 180 degrees. So this is definition of linear pair. Now they go on and they use that information. They said, well, if 1 and 2 are a linear pair, then the measure of angle 1 plus the measure of angle 2 has got to be 180 degrees. And 3 plus 2 has got to be 180. That is definition of supplementary. Because we knew they were a linear pair, they made a straight line, so they have to add up to 180. That's the definition of supplementary. Now look what they did. They had 1 plus 2 equals 180, 3 plus 2 equals 180, and now they have 1 plus 2 equals 3 plus 2. How come they can do that? I'll give you a hint. They took this 180, and instead of writing 180, they knew that this right here was also equal to 180, so they replaced that. So it's substitution. Now what did they do? They had 1 plus 2 equals 3 plus 2. Now they just have 1 equals 3. Because what did they do? They canceled it out. But how do you cancel it out? They subtracted it from both sides, right? That is the subtraction property of equality. And we're going to just keep doing these. We're just going to keep going, okay? So when you're done writing that, let's slide over to slide number 6. In slide number 6, we've got 2 angles. I'm going to leave this up there for a little bit longer so you can finish writing. I'm going to read it. It says the statements for a 2-column proof are to show that if the measure of angle y equals the measure of angle z, then x equals 100. And that all the statements are given below. Complete the proof by providing the reasons. What's all that? It's the given. First step's always going to be all the information they give you. So it's given. Now what did they give us? They told us that the measure of angle y equals the measure. So these two are equal, right? They told us that. And then they gave us expressions. They said y equals this expression and z equals that expression. So right from there, they jumped and they wrote this equation. 2x minus 90 equals x plus 10. They just plugged them in. Or in other words, they did what? Yeah, substitution. It's almost like double substitution, right? They replaced the y with that expression. They replaced the z with the other expression. Now, from B to C, look at this line into this line. What did they do there? They did, didn't they? They minus x. So they subtracted the same thing from both sides. Subtraction property of equality. And then they had x minus 90 equals 10, and now they have x equals 100, because what did they do for the last step? What would you do, right? You'd have to add 90 to both sides, or the addition property of equality. All right. I feel like you guys might be getting the hang of this. We're going to do 2 more on this sheet of paper, on this notes. So do you see how we're taking the stuff we know about geometry and now they're adding in some algebra? So we're not just forgetting about that algebra stuff we learned last semester. Slide number 7. We have 2 lines over here, 2 line segments that intersect each other, right? They tell us, given that the measure of angle 1 equals the measure of angle 2, and they tell us that angle 1 and angle 2 are supplementary. They want you to prove that 1 and 2 are right angles. So, guess what the first statement is? Given. They told us angle 1 and angle 2, oh gosh, I'm sorry. There are two proofs on here. This is a paragraph proof. My bad, guys. So measure of angle 1 plus the measure of angle 2 equals what? Equal what, Olivia? So measure of 1 plus the measure of 2 better equal what? What does that mean if they're supplementary? It means they equal 180. Why? Because they're supplementary. They say since they are supplementary. Since measure of angle 1 equals measure of angle 2, then look what they did. Measure of 1 plus measure of 1 equals 180. What did they do? Yeah, they substituted the measure of angle 2 with measure of angle 1. Solving that equation, because it's 2 of them and then you divide by 2, means the measure of angle 1 equals 90 degrees. And since the measure of angle 1 equals measure of angle 2, then angle 2 is also 90 degrees. Therefore, they're right angles. So that's your paragraph proof. I'm not going to make you do one like that. Okay. Well, it doesn't really matter. On the next one, it's given, right? However, this one's a little bit different. We're still using that drawing up there, that diagram. But we're talking about each line segment. E.g., I'm pretty sure that this is supposed to be G up here. E.g. Equals 3x minus 1. E.d. equals 2x plus 4. And then they say, hey, EG is equal to ED. So prove that x is 5. Yeah, substitution, right? Because they took this and they substituted. Okay, now looking at B to C, what did they do? So, subtraction. Why did I write it out? And then the last one, addition. Okay. Some of you are like working ahead and already have those answers in, so awesome job. Okay, one more on this sheet, and then we're going to move on to the individual one. Okay, let's see. Parallel lines cut M and N are cut by transversal T, so they tell us they're parallel. And they tell us that 2 and 3 are supplementary. Oh, no, I'm sorry. We're supposed to prove that they're supplementary. What does supplementary mean? So if I'm proving that they're supplementary, basically I have to prove that they add up to 180, right? Okay. Or something like that. So let's see. What goes in this blank? Right? M is parallel to N, transversal T. That's our given. M is parallel to M, and they are cut by a transversal. There's not enough room for me to write all that in there because it's little. It's given. Angle 1 and angle 2 form a straight angle. We agree? Yeah. Why is that? Any guess? There's a couple things you could say. I'm going to say definition of a linear pair, because they are right next to each other and they make a straight line, so they form a linear pair. And then they jump to, they don't give us the statement, but they tell us it's the definition of supplementary angles. What does that mean? Probably the measure of angle 1 plus the measure of angle 2 equals 180 degrees. I know that because they form a straight angle. The measure of angle 1 plus the measure of angle 2 is supplementary. It's 180 degrees. Definition of supplementary angles. Now they jump to angle 1 equals angle 3. Why do we know that angle 1 is equal to angle 3? Look at the picture. Ah, there you go. Corresponding angles. Now, technically, we should have to write because corresponding angles are congruent when lines are parallel. I am not going to make you do that. If you tell me because they're corresponding, I'm going to be like, high five. Nice job. Okay? This is not a grammar class. I'm not going to make you write all that. Okay, so the next reason is substitution. So they're taking and replacing something. Well, what did they just tell us? Angle 1 is equal to angle 3. Look at what we wrote up here. Angle 1 plus angle 2 is 180. So the measure of angle 3 plus the measure of angle 2 equals 180. What they did there is they took this one and they substituted measure of angle, that's what we did actually, measure of angle 3 because we knew they were equal. And if the angle 3 plus the angle 2 is 180 degrees, I can say that angle 2 and angle 3 are supplementary angles because why? Definition of supplementary angles. That's what it means. If they add up to 180 degrees, that is the definition of supplementary. Okay?